This is Saxon Algebra 2, Lesson 116, talking of fundamental counting principles and permutations, probabilities, and independent events. So this is a fun lesson. I always enjoy doing this one. Let's start with, so the first we're going to deal with is how many ways we can do things. And I'm going to start with the letters A, B, and C. We got the letters A, B, and C. How many different ways can I arrange those three letters? And if you can envision, you might have this at home, if you can envision the alphabet blocks that you had when you were a little child, you can actually manually do this. How many ways can I arrange A, B, and C? Well, that's one way. That's the first way, A, B, and C. Another way is by swapping the B and the C. So I've gotten two ways to arrange the three letters where the A is in the first position. The third way I'm going to choose to be when I take the A and B and swap them. So now I have the B in the first position and then A and C. And the fourth way is going to be when the B is in the first position and then I swap the A and C. So I got four ways now, but we're not done. I could start my list with the C, and that's going to be the last two ways. I can either have C with A second and B third, or C with B second and A third. So I have three letters, and I am arranging them. I can arrange them in 6 different ways. So when I only have 3 letters, that one's pretty easy. But what if I had 10 letters? So I need to find a pattern to this arranging. And here's our pattern. We got 3 places that we need to place these 3 letters. And when I go to place something in the first position, I have 3 letters to choose from. I could put an A there, a B there, or a C there. So I have 3 options for that one. But once I have placed the one letter there, remember, think about it here. Once I put the A in the first spot, then I only had 2 choices for the second spot. I either could put a B there or a C. So there's my 2 choices there. And once I've placed my first spot and my second spot, let's say it was this one. I put the A in the first spot and the B in the second spot. The only block I have left is the C. There's only one. So when I am doing combinations, how many ways I can do things, I can actually use this by multiplying, and it will give me my answer. 3 times 2 times 1, because I have 3 items that I'm putting in order. 3 times 2 times 1, there's 6 ways I can do that. And if I added a D, A, B, C, D. If I added a D to my mix, so now go in little brother or sister's room and get a 4th block, what's that going to change? How's that going to change my list? And I propose that it actually means I got 4 I need to arrange. I got 4 choices for the first, then 3, then 2, then 1. So by adding 1 more block, I now have 4 times as many ways to arrange those. And it grows that rapidly. So one place that we might do this, let me say that too. We were using actual blocks here. We were pretending that we had actual blocks. So we could not use 2 A's or 3 A's because we only have 1 A and 1 B and 1 C. But there are times when we could repeat. This is not repeating. There are times that we could repeat. So if we posed that, if we just have how many ways can we arrange A, B, and C even if we repeat, then you can see these would be true, but we could also do these. There's several more. I'm not going to list them all. So let's think about the scenario here. We said once we placed the first block, we only had 2 to choose from. But if they're not actual blocks, but we're writing on the board, I need to fill in 3 spaces. I have 3 choices for the first space, 3 choices for the second space, and 3 choices for the third space. So if I can repeat in this scenario, then that's 27 ways I can arrange those 3 blocks instead of just 6. If I added the D, then it would be 4 to the 4th power, which I don't know offhand what that is. It'd be 16 times 16, so that'd be 160 and 36 and 9 and 6. Oh yeah, 256. If we added the D, so we've got 4. And we want to be able to repeat, we've got 256 ways we could arrange them.